Okay, section 1-4, angles, objective 2, 3, and 4. Let's start with warm-up. Using the protractor, find the measure of the angles below. Okay, so you find the measure of angle 1, measure of angle 2, measure of angle 3. So stop the video here and get a protractor and measure it. The protractor I have is totally beaten up, but it still works. So, okay, so what you do is you put this dot, the center of the protractor, to the vertex. This is the vertex of the angle, and then you line up one of the lines with this, one of the lines that makes the angle, and then read this line to this number. So 0 to, don't start reading for 180 and then read this, then you're going to get the wrong angle. You have to start from 0, 0, 10, 20, 30, that's a 35. Here's the degree sign. Alright, measure of angle 2. Align with vertex and one of the lines, and 10, 20, 30. This is 30 degree. And this one, the measure of angle 3, is 10, 15. So here's a question for you. What do you think is the measure of angle TER is? These two angles together. Yeah, it should be 45, right? Let's double check. Right, so 10, 20, 30, 40, 45. Okay, so it is 45. So that's the angle addition postulate. You can add measure of two angles to get to the angle together. That's coming out in this section. Okay? All right. Okay, so we are here. Angles. We're almost done with chapter 1 here. All right, so objective 414 is 2 and 3 and 4. So 2, name angles and find their measures. So you remember we did in 1-3 the distance for the segment. So the distance is for the segment, and measure of angle is for the angles. The measure is for angles. The distance is for the segment. Okay. Okay, and there is a symbol for that. State and use the segment angle addition postulate. That's the one we did in the warm-up. The 30 plus 15 is 45. That's angle addition postulate. Recognize what you can conclude from a diagram. Okay, now we do this in a class. It's not going to be in this video because it's like 1-3. It's a lot of definition. It's a little bit long. Right, so name the angles. These are the same ones that we did in the warm-up, right? So how do you want to call this angle here? There are multiple ways to call it. You can call it angle 1, because here's a number. Can you call it angle B? Yeah, you can call it angle B because there's only one angle that is made by this, okay? Well, this is also an angle B, but in this class, when we say just the angle, we always looking for the smaller one. This is called obtuse angle, and this is acute angle, which is coming up now. Here's some terminologies. These are called sides. This is side. And like I said, this is vertex. Okay? And angle, the symbol for angle is this. Okay? Or you can just do this. But I like this because this kind of look like an L. But either way is fine. Angle is, so angle is a figure formed by two rays. These are rays, right? Ray BA and ray BC. Two rays that have the same endpoint common. Same endpoint means common endpoint. And this common endpoint is called vertex. Okay, so that's the definition of an angle. Now, this angle, you can call it angle 1. You can also call it angle B. But more typically, we use the alphabets, the forming the rays. So you can call it angle A, B, C. Make sure the vertex, the points for the vertex, comes in the middle. Okay? Because if I said angle, let's see, CAB, for example, then that's this angle right here. That's the angle CAB. Okay, so make sure the alphabet that corresponds to the common endpoints comes in the middle when you're using three alphabets. But you can also call this CBA. Okay, that's the same angle, ABC or CBA, as long as the B is in the middle. Okay, now what about this one right here? Can you call, so you can call this angle 2 and angle 3, and can you call it angle E? Which one's the angle E here? You think that this whole thing is angle E, right? No, but you can't call it that way, because angle E can be this, or this, or this. There are three possibilities for angle E. So when there are more than one angle formed by the vertex, then you cannot use this one anymore. You have to use three alphabets. So the angle 2, you can also call it angle with three alphabet R, E, S, or S, E, R. You can call it this way. And angle 3, you can call it SET or TES. Okay? Or you can call it angle 2 or 3 if there's a number there. But you don't always have a number, then you have to use the three alphabet. Now, when you want to refer to this big angle here, the together angle, then you'd say R, E, T, or angle T, E, R. Okay? But you cannot say angle E. That's no good. Okay? Next page. Practice 1. Okay, name the vertex and the side of the given angle. Alright, try this and come back. Okay. Now angle 4. Where's angle 4? Right here. Okay. So the sides are this and this, right? So you can call it ray CB, or if you said ray CA, that's fine. Those are the same thing. And the other ray is CD, right? Those are the sides, and vertex is C. Okay, so these are sides. This is vertex. Okay, angle 1 is over here, and angle 6 is over here. If you have confusion with this, we address this in the class. Name 3 angles that have B as the vertex. How many angles have D as a vertex? Okay, so try these, okay, and then we check these answers in the class. All right, measures angle, objective 2B. All right, acute angle, right angle, obtuse angle, and straight angles. So those are new terms. Here's a protractor, right? So let's just measure this angle, this angle, separately. So, and here's how you write it. So this is angle WOZ, right? This is a geometric term, it's a figure. So you cannot do equal, say, what is this, 45 degree? No, you cannot say that because this is a numerical value. You cannot equal the figure. So how do we make this numerical value? You add m in front of it. Now its measure of angle WOZ is 45. Measure of angle WOV is also 45 degree. And measure of angle VOY or YOB, doesn't matter, will be what? 1, 2, 3, 4, 5. So that's a 50 degree. The measure of angle Y or X is 1, 2, 3, 4, 40 degree. Okay. How about measure of angle VOZ? Now, VOZ, so this angle right here. Now, you can do two things. You can count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 90 degree. Or you can add them, right? Because we already measured this in this. So 45 plus 45 is 90. What about measure of angle ZOY? So you can add 90 and then VOY plus 50. So 90 plus 50 should be 140, right? And how about measure of angle YOW? YOW. You can do a couple ways to go. You can either count here 1, 2, 3, 4, 5, 6, 7, 8, 9 and a half, so it's 95. Or you can do, this was 50 and that's 45, so 50 plus 45, 95. Or you can do is, this was 140, right? 140 minus 45, you get to 95. Either way, you get the same answer. Now, acute angle is any angle less than 90, okay? So just list the angles, all the possible angles are less than 90 here. Right angle, so this is measure of angle is less than 90 degree. Measure of angle is exactly 90 degree. Obtuse angle means measure of angle is greater than 90 degree. Okay, and the straight angle is measure of angle is exactly 180. Okay, and we don't really deal with right now the angle is bigger than 180. Okay, so these are the terms. So just list these angles using alphabets here. Okay, and sorry, strictly speaking, the obtuse angle should be greater than 90 but less than 180. Okay, so less than 90, exactly 90. Between 90 and 180 is the obtuse angle, and the straight angle is exactly 180. Practice 2. State whether the angle appears to be acute, right, obtuse, or straight, then estimate its measure. Okay, you can do this. Okay, and we check tomorrow. Right, protractor posterior. Here's the posterior number 3 and number 4. Okay, the protractor posterior is like a ruler posterior. Ruler posterior is for segment. Protractor posterior is for angles. Okay, on line AB in a given plane, choose any point O between A and B. Any point O between A and B. Consider ray OA and ray OB, and all the rays that can be drawn from O on one side of the line AB. These rays can be paired with the real numbers from 0 to 180 in such a way that ray OA is paired with 0, ray OB is with 180. If the OP is paired with X and ray OQ is paired with Y, the measure of angle POQ is the absolute value of X minus Y. Okay, so you can assign for any angles the numerical value, just like the ruler portrait. Okay, and also you can subtract it to get the absolute value, just like the distance. Okay, and here is the angle addition portrait. So the measure of angle AOB plus measure of angle BOC is the measure of angle AOC. Okay, so we can't prove this, we just accept as truth. Okay, if the AOC is a straight angle and B is any point not on AC, then measure of angle AOB plus measure of angle BOC equal 180. Okay. And here's a practice. Measure of angle 7 plus measure of angle 6 should be measure of angle what? This is just expressing. So this would be this angle right here, right? That would be DDE. Measure of angle 6 plus measure of angle 5. You can do this, right? Measure of angle 2 plus measure of angle 3. There is no measure of angle here, right? But this is a straight line. So this is actually asking for the number 180 degree. BD bisects the measure of angle CDA. Okay, so bisects the measure of the ray DB bisects the angle CDA. So that means this line, this ray is bisecting this angle. And if the angle is bisected, that means these are the same angle. Okay, so the measure of angle 5 is the measure of angle. Now, I feel like something is missing here. When angles are congruent, right? This is congruent, means that measure of angles are the same. So measure of angle 5 is measure of angle 6, then that's equal. The numerical value are the same, and angle 5 is congruent angle 6. Just like the segment and the distance, that's the numerical value, so you use equal. This is the figure, geometric term, so it's a congruent. Okay. Okay, so I'm gonna do this and this on the video. We do this one in the class, and then the rest is in the class. So that's it for tonight. Okay. Here, congruent angles. It's on page 9. Now, this problem should have been after, but anyway, it's okay. Alright, so congruent angle means they have a same measure of angles. Okay, so it doesn't have to be oriented the same way. It doesn't have to be in the same orientation. It's a different orientation as long as it's the same measure of angle. These, so angle R is congruent to angle S. Okay, you can use one alphabet because that's the only angle that is represented by this common vertex. Okay, we're going to do the adjacent angles in the class because it's a little tricky. And this one, the bisector of an angle, means the ray YW bisects, meaning that these two angles formed by that ray are congruent. Okay, I think that's it for today. And you can do this. Okay, and then we check these tomorrow in the class. Okay, we are done.